guys, today we're looking at exercise 7B, and this is talking about inverse relations. So up until this point, we've considered that if a function isn't one-to-one, it doesn't have an inverse. But that's not strictly true. If a function is not one-to-one, it has an inverse, but the inverse will be a relation rather than a function. So here, they're asking us to find the inverse of the function f of x is 4x plus 1 squared, and they want us to sketch both relations on the one set of axes. Okay, so as usual, in order to find an inverse, we swap the x and y, and then we just solve for y. So what I've done here, I have taken the 4 over the other side. I'm going to square root that. Don't forget that you've got the plus or minus. So plus or minus square root x on 4 will give you x on 4 when that is squared. So you must remember the plus or minus. And finally, I subtract 1. The way we write that is like that. And notice how the negative 1 comes before the plus or minus half root x. The half root x, that's come from I've solved root 4. So where we've got x over root x over root 4, root 4 is 2. So that's 1 over 2, and root x stays as it is. Here's the graph here. The top graph being your 4x plus 1 squared, and then this one that goes kind of sideways. It looks the same as your original, but it's just plain on the side, and that is our negative 1 plus or minus half of root x graph. Notice because of the plus or minus, that's why we've got the two parts to that graph. Notice how if we just had one part, it would be your root x graph. You would be able to recognise that as your root x style graph. Next, we want to find the inverse of h of x is e to the power of modulus x. So once again, let's swap x and y. Here's the graph of e to the power of mod x, by the way. And the range of that graph is 1 to infinity. Just to show you, if we do the straight line test, we see, well, it's a function but not a one-to-one function. So the inverse is going to be a relation. So we swap around x and y, and we solve for y. And notice that when we have the modulus of y, to undo that, we end up with plus or minus log ex. And we've got to have that x is greater than or equal to 1. Next, we want to find the inverse of f of x equals x to the power of 2/3 plus 16. Once again, here is the graph. And let's just swap around x and y. It's not a one-to-one function, so the inverse will be a relation. Swap around x and y, and we end up with y squared is x minus 16 cubed, and then we square root that, and remember, of course, the plus or minus sign there. That's what gives us the two parts to the graph. Try it on your calculator with just one part, and you'll see what I mean by the two parts. Now we want to find the inverse of x to the power of 2/3 plus 1, and we're going to use CAS for that. In your main area, go to interactive, and then we go to solve. Once you're in solve, you get this screen here, and you enter your equation in x equals y to the power of 2/3 plus 1, and we must change the variable to y, because remember we're solving for y. It'll automatically have x there, so make sure you do that, otherwise you'll just get out the same as what you put in. There it is there. Here's y, we click OK, and we end up with y equals negative x minus 1, it should be, not 16, to the power of 3 halves, comma, y equals x minus 16 to the power of 3 halves. So it's showing you the two parts of that. Now we want to find the inverse of g, where g of x is all real numbers except for 1, and it's 1 over x minus 1 squared. So there is 1 over x minus 1 squared. Once again, it's not a one-to-one function, so we know that the inverse will be a relation rather than a function. So swap around x and y. And then how I've done that, I've multiplied by y minus 1 squared on both sides, and then divided by x on both sides. So that's how we just swap those around. And then I take the square root, plus or minus of course, and then finally add 1. And that's what it would look like. And that's all of 7b.